Okay, here we go with page 2 of the Algebra 2 Fall Final Review. Looks like we're going to be graphing some quadratics from multiple different forms here. There are some edits to this page you want to make sure you pay attention to here on number 10 and number 12, so I've already highlighted those, so make sure you also have those changed. But we are going to be starting with number 9, which is in standard form. So if I'm going to find the vertex and the line of symmetry here, I need to make sure I'm using this formula, which is x equals negative b over 2a. That's going to help me find my line of symmetry, so my b value being negative 8. So negative 8 over 2 times my a value is 1. So negative 8 over positive 8 over 2, which would be 4. So here at 4, I'm going to have my line of symmetry. So I'm drawing that in. X equals 4. Sorry for that. And then I'm going to plug 4 into the equation. So I'm going to find what f of 4 is. So 4 squared minus 8 times 4 plus 20. So 16 minus 32 plus 20. 16 minus 32 is negative 16 plus 20 is 4. So my vertex is at 4. Plugged 4 in, got 4 back out. So my vertex is at 4, 4. Go ahead and label that with a V. So there's my vertex, my line of symmetry. It wants me to do maximum or minimum value. I'm going to go ahead and find some more points first. So what I'm going to do is find f of 3, since 3 is right next to 4. I'm going to move to the left as I find points. So 3 squared minus 8 times 3 plus 20. So 3 squared is 9. 8 times 3 is 24 plus 20. 9 minus 24 is negative 15 plus 20 is 5. So plugged in 3, got 5 out. That will be 3, 5 would be here, and that would mirror over to here. Not much space in this problem, but oh well. Let's see, and then I'm going to go find 2, so I found 4 already, I'm going to find 3 already, I'm going to find 2. So 2 squared minus 8 times 2 plus 20. So 4 minus 16 plus 20. 4 minus 16 would be negative 12 plus 20 would be 8. So plugged in 2, got 8 as my answer. That's very good. 2, 8. Should be right here. And mirror that to there. So I shall draw that parabola now. And then it's going to have a minimum at y equals 4. Alright, so there's number 9. Number 10 is in vertex form, so that means I know the vertex right away just by looking, which is going to be negative 2, negative 6. It's also pretty easy because I know that the axis of symmetry is the same value as the vertex for as the x value, so that's negative 2. So those are easy to find from vertex form. So I'm going to go ahead and draw on the axis of symmetry. So x equals negative 2. No, the vertex is at negative 6. That would be there. And I need some more points. So just like last time, I'm going to plug in numbers right around that. So I'm going to start with -3, since just go to the left. So that would be -3 plus 2 squared minus 6, which is -1 squared, which is 1, minus 6, which is -5. So -3, -5. So right here, and then mirror that over. And then I'm going to plug in -4. So -4 plus 2 squared minus 6. -4 plus 2 is -2. -2 squared is 4. 4 minus 6 is -2. So -4, -2. Which is right here. Then 0, 2, and then I can draw my parabola. And this one also has a minimum, but it's at y equals -6. Alright, there's 9 and 10. Number 11 is also in vertex form, so just the same way I was doing the last one. So it means we know right off the bat where our vertex is, and it's at -3, -5, because of those two numbers right there. So -3, and that means my axis of symmetry, which I just started drawing, is at -3, so x equals -3. And -3, -5 is right here, so that's my vertex. Let's see, need some more points. So, for fun, I'll plug in -2 this time. So -3 times -2 plus 3 squared minus 5. So -2 plus 3 is 1. 1 squared is 1. So I get -3 times 1 minus 5. So -3 times 1, of course, is -3. Minus 5 is -8. So that was at -2, -8. Let me mirror that over there. So this graph is going down so quickly, I'm actually not going to be able to plot any more points. So that's all I'm able to see for this guy. This one has a maximum at y equals -5. And this last one here, so this is in standard form. So I'm going to start with the x equals -b over 2a. So that would be x equals -b, so -8 all over 2 times 2. So -8 divided by 4, which is -2. So at -2, my axis of symmetry, so I'm going to plug in -2. So 2 times -2 squared plus 8 times -2 plus 6. So make sure you're doing order of operations first. So this would be 2 times -2 squared, which would be 4, plus 8 times -2, which would be -16, plus 6. So 8 minus 16 plus 6. So 8 minus 16 is -8, plus 6 is -2. So I plugged in -2, got -2. So that's where my vertex is. So I need some points next to -2. So like -1. So 2 times -1 squared plus 8 times -1 plus 6. So 2 times -1 squared. So -1 squared first is 1. So 2 times 1, which is 2. 8 times -1, which is -8, and then plus 6. So 2 minus 8 is -6, plus 6 is 0. So plugging in -1, we got 0 as an answer. That means it'll reflect to here. Then, so I went -2, -1, so 0 would make sense to go next. Well, I don't need to do too much work on 0 because I know that the C value is the y-intercept. So if I plug in 0, I'm going to get 6. So 0, 6. Go here and then reflect over to here. So I'm going to draw my parabola now. Look at that. And then this one has a minimum at y equals -2. Alright, there's all the quadratic graphing from standard and vertex form. Move down to solving these absolute value equations. Definitely one of the things we want to remember about solving absolute value equations is that they have two answers, and that sometimes one of those answers may not work, so that's where we're checking for those extraneous solutions. So checking our answers first. What I do need to think about for solving is that the absolute value piece does need to be by itself first before I'm allowed to solve for that. So what I'm looking to do is isolating this here for 13, so that means I'm going to get rid of that 5. So I'm going to divide both sides by 5. So I have absolute value of x minus 2 equals 6. And now we split the problem into 2 to get rid of those. The idea here is like if I said the absolute value of 6 was equal to 5, is that x could equal 5 or x could equal -5. So as we're splitting this problem into 2, we have x minus 2 equals 6, but x minus 2 could also equal -6. So notice how the x minus 2 didn't change. That's a pretty common mistake. People think it needs to be x plus 2. That didn't happen. It's the 6 that changed the second time. And now we have two pretty easy equations to solve. So plus 2 plus 2. So x equals 8. Plus 2 plus 2. X equals -4. So here's my two possible answers. I'm going to check those both before I say if they're right or not. And you make sure always go back to the original equation, up here, and solve that. Don't solve from anywhere else in the problem. So checking 8. So 5 times 8 minus 2, absolute value of that equals 30. So that'd be 5 times the absolute value of 6, which is 30. And that should be 5 times 6, which is 30. So 8 works. Then I'm going to check -4. That's 5 times absolute value. So -4 minus 2 equals 30. 5 times the absolute value of -6 is 30, which is 5 times 6, which is 30. So those both worked. So we'll circle both those. Similar idea for the next one. I want to start off by making sure that the absolute value is isolated. So this one is isolated, so I don't have to worry about that. So that means I can go straight to the splitting part of the problem. Now, this one's a little more complex with the binomial on the right side here, but we can still do that. Not a big deal. So I'm going to go ahead and bring it down pretty much the way it is. So 3x plus 2. So get rid of those bars, equals 4x plus 5. And then the second one will be 3x plus 2, so that doesn't change. But this time we need to make everything there the opposite, so it's -4x minus 5. And so I'm going to solve these two equations. So I'm going to get the x's to the same side. So I'm going to subtract 3x. Since the x's are coming to the right, the numbers are going to the left, so subtract 5. Subtract 5. That's gone. That's a 5 here. So that means that's gone. So that leaves me with -3 equals, and 4x minus x. 3x is just x. So x equals -3. There's one of my answers. So this time I'm going to add 4x to this side. And since the number variable is going to the left, I'm going to take the numbers to the right. So those will cancel, leaving me with 7x. So 7x equals -7 divided by 7. So x equals -1. Alright, so here's our two answers. So I'm going to check -3. Again, make sure you plug back into the original equation. Do not plug back into anything else. So 3 times -3 plus 2 equals 4 times -3 plus 5. Just simplify, don't solve. So 3 times -3 is -9 plus 2. Absolute value of that, so we have absolute value of -7, which is 7. Over here I have -12 plus 5, and that gives me -7, and 7 does not equal -7. So this answer does not work. So what that means is that -3 is extraneous, and I know it's extraneous, not just wrong, because it's just the sign that's off. It doesn't say like 7 equals 12, or 7 equals 0, or 7 equals -43. It just says 7 equals -7. So just because the sign is off, it's wrong. That tells us it's extraneous, not just wrong. I check -1. Just because -3 was extraneous does not mean this one will work. I need to check both. Again, plug back into the original equation. So 3 times -1 plus 2, absolute value of that equals 4 times -1 plus 5. So on the left side here, I get -3 plus 2 in the absolute value, which is a -1, which is 1. And then -4 plus 5, which is 1, So -1 does work. So there are my two answers for number 14. So that's solving absolute value equations and checking for extraneous answers.